Hi, everybody. My name is Alicia Collins. I'm your host for the speaker series. I'm the creativity catalyst at Brilliant Labs, and I'm super excited to have with us Ken Nakagaki, my former colleague. He is an A-TUIs researcher, an interaction designer from Japan, and he's also studied in United States. He was at the Massachusetts Institute of Technology at the Media Lab with Hiroshi Ishii, and he will start a lab, I think it's called Actuated Experience, at the University of Chicago, where he will be joining as an assistant professor. So I'm really looking forward to your talk, Ken. It's very exciting. Welcome.
Yeah, thank you so much. Should I start sharing my screen? Oh. Do you hear me? Oh,
We hear you.
Okay, good. Alrighty. Oh, okay. I think while I'm sharing, I'm not see the chat, but you can intervene me if you need to.
Sure.
Cool. Thank you so much, Alicia, for a great introduction. Everyone for joining from a different part of Canada, or maybe some people are watching from outside of Canada. Quick self-introduction. My name is Ken. Again, I just completed my PhD study at the MIT Media Lab this summer. And as Alicia said, I'm starting my own lab at the University of Chicago and starting my own lab there, which is really exciting. And so my research is about I'm an interaction designer and also a researcher at the field of human-computer interaction, which I would love to talk in today's talk. But before going to the content itself, I would like to ask questions. Do you remember squishing clay between fingers? Do you remember twisting strings into geometric shapes? Do you remember tinkering with gears of a mechanical toy? Probably many of you are rather younger generation, so it's more, maybe it's not only about remember, but you might be actively playing with these materials. But I do care a lot about, this tangible haptic feeling of this physical material, that it's really amazing. It's really fun and satisfying, to squishing materials, clays, or, twisting materials into different shapes and stuff like that. And so there is this kind of like this fundamental love to physical materials around us, which I hope many of you agree in some extent. And as I said, I'm a researcher at the Human-Computer Interaction, HCI in short. So this, to briefly describe what this research field is about, it's about designing the interaction in between human and computer. So when you look at computers or think about computers, I think they all look like different forms like this. Maybe typically you think about laptop or desktop computers, or nowadays it's like smartphone or tablet, etc. But when you think in terms of the research domains, it is about how we can design this interaction with human computer. And nowadays we use lots of screens, keyboards, and mouse, etc. And one thing I believe is, when I think about this joy of touching physical materials around us, these computers really lack the quality of these touch. They are already, it's great that I can give different information with the visual feedback, in a screen, but it lacks the tangibility. So my research is about, I name it Actuated Tangible User Interfaces, A-TUIs for short. And the video you are seeing behind this text is basically it's not my work, but what inspired me to come to the MIT. So this user interface is basically an emerging type of user interface that can physically actuate, meaning shape-changing or move, for tangible interactions. So, as you can kind of see, digital information is not anymore flat and only visual, but it can give you can give a dynamic physical form that people can, touch and feel. And in terms of this actuate, when you look up a dictionary, you can find it's causing a machine or device to operate. So it's a little bit like this engineering word, or engineering vocabulary. When you describe motors, using motors to spin and doing stuff like that is basically what we call actuate. And very brief history about this domain of tangible user interfaces. So I have been in this group, research group named Tangible Media Group at MIT under Professor Hiroshi Ishii, and his lab has been doing this very cool work to bring the tangibility to the field of human-computer interaction in the past like 25 years. It's really crazy that he even had this idea in the 90s. And my research have been working on different kind of like vision-driven research, where at 90s it was about this tangible user interface. Recently, we as a research group, we talk about this vision of radical atoms, imagining the future of material that can dynamically shift by computation. And if you're also like interested in this topic, if you this is just like one image collecting lots of papers in our field. I think one keyword is also like shape-changing interfaces, thinking about how these user interfaces can start shape-changing. Anyway, back to my motivation. So in terms of doing research in this actuated TUI domain, I want to bring the quality of touching and manipulating different materials around us. And motivated by this work, I have developed something like this, which is kind of like based on this joy of squishing clays. I'm going to talk a little bit more detail about this project later, but just want to give you an overview. Or some kind of like shape-shifting strings, or some kind of like mechanical that like activate different gears and mechanism that makes really cool expression physically. So in my research, I invent novel actuated TUIs that blend joy of physical action with robotic actuation and digital computation. And that sounds complicated, but yeah, especially if you are looking into this research field, there's lots of like it's a little bit like interdisciplinary research where there's lots of topics incorporated. I'm not going to talk about like detail of each research field for now, but it is about this user interface research. There's lots of history about that, but also in terms of technology, I utilize lots of like robotics technology because I build something that moves and dynamically shift and move around. So you could take a look if you are interested in my talk. If you got interested in the topic of my talk, you could take a look into that. Because I only have like 30 minutes, I'm not going to ever cover all the research topic shown here, but I would like to pick like one or few projects from each of them and talk about it and end my talk with my new lab I'm building. The first topic is about this materiality and the perceptual design. So the question when I joined the group, one of the questions when I joined the group was like, that shape display project, which is basically these pins moving up and down. But those hardware and devices are really cool that they can change shape. But how we can create, express things that have beyond shapes. By saying so, what I mean is, when we look at physical materials around us, surely there is lots of different shapes and materials. I have this cup, but also in addition to shape, there is different materiality, right? Like different flexibility, squishiness, rubbery, etc. So in this project Materiality, we explored using this shape-changing display interface how we can create new material expressions. This work was also motivated, by really crazy computer graphics. If you know any like computer graphics movies, like Pixar movies and etc., you see really cool rendering of realistic materials. It's advancing year by year, but they are always behind the screen and you are never able to touch them, right? So this is the video of our Materiality, where all of these like white pins are plastic basically, but once you touch and press them, they behave like different materials, and this can be instantly switched between different materials, and you can switch control its like flexibility, elasticity, and viscosity, so would also act like fluid. So by having this, you can kind of like imagine you can render different types of digital image with physical shapes, but also with different materials. So this is almost like a future of clay that would have switch, different shape, but you can also add different, liquid material or solid material combined together. It's cool to utilize this also for like education purpose, that we can display different information that maybe doctors can medical students can learn the stiffness of tumor by representing those shapes. And technically, we have developed this interaction framework where I'm not going to detail, but there is, in the computer, we have this like physics simulation in the computer, but we have this shape-changing user interface that detect how we are pressing, and that is passed to the physics simulation and provide output. So it will be created. It will create the real-time, dynamic shape. So people get the illusion they are touching different types of material. And our physics emulation really allow creating 3 different material properties. So kind of like if you imagine touching between like concrete to form, right? The concrete is really solid, form it really deforms a lot when you soft. That's like flexibility. Elasticity is this kind of like ability for material to comes back really quick. So I think clay doesn't come back really quick, while when you rubber or spring, it can make this bumpy behaviors. And viscosity basically is like a fluid resist material. Water is have create this like really smooth ripple, but honey is a more viscous that will make ripple flow. So that is kind of like the basic things, but also I think there are other material properties it could be represent further, which is fun to imagine. And in terms of this like material emulator, we have this like simulation model. It's almost like we mathematically create this virtual spring. So our computer can emulate this. So each pin would behave in different way by tuning these materials. They're like math equations, which I'm not going to in detail, but the point is in the computer or program or this equation, by tuning this property, you can quickly create different material expression. And as we do research, we publish this paper, we have this hypothesis of rendering material property, and we need to verify it through user study. So we found people rated different softness, flexibility, elasticity, viscosity in different ways, and you can see this in the graph that our hypothesis really worked. What was interesting beyond these numbers was basically how people really interacted with this, right? So when we think about different this like haptic, maybe you have heard about like haptic glove and stuff like that, but I think the quality of like this actuated tangible interface is basically the digital data exists in front of you, so we can you're not really constrained only with glove shape, right? You can put your entire body around or your arm, and it's really up to you how you interact with it. And while we didn't really ask them how to touch it, it was really our surprise that they really playfully found the different ways they can touch and feel the material property of this. And it's really fun. Hope you get the chance to try these demos at some point. So that was basically this first group. You can find all the videos on my webpage basically, but because I'm gonna quickly show. But the second group of project is basically what I call as this line-based form and interaction. So it's basically, when we think about shape-shifting materials or shape-shifting user interface, I was thinking of like different form factor, and I came up with this idea: what if we have a single line that can transform into different shapes? Line is really simple form that is really, something it's really ubiquitous. We can find in our daily life. We use line to draw or express information, right? And we also use lines or single yarn can transform into surface or solid shapes. So it's really simple that, line is such a simple form, but it has really versatile, opportunity to be designed for expression and interaction. So in this project line form, we have kind of like speculated what the future of, computer interface could look when they take a form of line with this dynamic transformation capability. And let me skip through a little bit. And so in this video, we share lots of like possible applications with this shape-changing line idea, where you could have this mobile device that wrap around your wrist as like a smart or something, and it gives haptic feedback. Once you rip it off, it transforms into this smartphone shape form factor. You can maybe text or something. And when you get the phone call, it transforms into this phone shape, so you can give a call. And this shape-changing line can be, use cables. Lots of things become wireless, but we still have, having a physical cable is really nice. And the first one you see here is basically how when you connect this cable to a lamp, the cable itself turn into a lamp stand and a lever. So depending on what you connect with, the cable could transform into a different shape, give different functionality. Or more simply, cable is for charging, your phone or transmitting invisible data. So that could be represented using this dynamic motion too. And the line is a form factor that is such a, malleable that you can easily like wrap around your body, just like bandage. So we were thinking like how this can be used for example, for rehabilitation. That can be, it's really easy only by wrapping around your body. You can, change stiffness, but also you could, record someone's emotions and replay on your body. So maybe, you can learn some kind of like sports and dancing through your body by wrapping around your body, wrapping around. Maybe having this would make your math class really fun too. This is almost like a shape-changing ruler, but it can create different like, mathematical graph and etc. And it can guide you, drawing different shapes. And the final here is kind of like showing how this could represent, for example, tangible computer graphic data. Then you can, directly manipulate this data by, playing around with this form. It can, snap to a different angle, etc. To technically build this system, we have, utilized snake technology. Maybe you have heard about this technology, but people are building, there are crazy researchers building these techniques to mimic snake robots. And oftentimes they are, building these systems to study and replicate the locomotion of snakes. And it is kind of like established research field itself. But technically, in the Lineform project, we did utilize technology of snake robotics, but we didn't want to look at as snake or animal or creature, but we wanted to look this as like what if this could be a future of materials that can transform? It's like a string or ropes or that can transform into different shapes. So it is kind of like utilizing certain existing technology, but one of the value is in like putting a new perspective into what this technology could be, beyond what existing researchers have done. And in paper, we kind of like define different like design space, etc. Well, I'm running out of time. Let me skip this one, but this was kind of like technically advanced version of line form that you can like cut and rejoin and do lots of cool stuff. And what I'm showing here is a video I created before building line form. So I had this crazy idea of shape changing like yarn or string that can transform into different shapes according to how you touch and interact. So this is almost like representing digital information, but you can really touch and modify it. We call this approach like, so this is not real working thing. I have no idea how to build such thing. It's more, kind of like stop motion, using a video like stop motion to create and to imagine. So for us, for me, the research process is always about, not only this prototype, but what you imagine in the future. Very exciting thing that is also like with the advancement of technology, this idea of bringing this line form to really thin form factor is coming close to reality. With my colleague, we in this year or 2 months ago, we have presented this new paper called OmniFiber. Now, this shaping capability woven to textiles. So essentially what we are wearing is all lines, right? Strings made of strings. So that could be imagining, every strings transforming is really cool to think about. And beyond that, there is lots of like ideas around this theme of shape changing line. And I think my research about form is almost like more of like a starting of a very exciting, research domain or idea. And what if it could be really tiny scale as DNA, or more how it can be used for art design expression is really cool too. So I hope to explore more along this idea. Last thread of research is basically about this idea of activating inert mechanisms or material. So these streams of idea started from this fun exploration, basically use this shape display to give life to this craft. So it's basically these are made of passive paper and wire materials, and we basically propose we found it's only by putting these materials on top of these shape displays, it start to give really cool animated expression. These shape display, pins moving up and downs are pretty cool, but with this putting this passive material on top, it adds a lot more expression beyond what shape display can do. And we have done this kind of like workshop to see how versatile and unique expression people create. And we were kind of like motivated how this could be extended further with this looking at this relationship of combining activated machines together with this passive material or mechanisms. So in my latest work, I presented this last year, and it's called Hermits, and we use a lot of different hardware setup, which is basically this like swarm robot device. So there's lots of research in this domain too, where lots of tiny robots move around and display information or haptic feedback. And I kind of like try to explore this, utilize this actuated hardware, but with adding passive mechanical systems. The reason I named this project Hermits is basically it's like a hermit crab idea, where these, imagining these swarm robots are the crab and they can like between. I think you will get better idea when you see this video. It's basically these cubes is basically able to like switch between these different mechanical shells. And the robots, these tiny robots are activating every single mechanical shells. And by, by where the robots themselves have really limited, can do really simple locomotion, by having this, almost like a costumes switching between from one to the other, it can do lots of different stuff. So again, you saw these like cubic robots and these mechanical shells, which I defined in my paper. And by utilizing this, we can combine them. So it's kind of like this robotic system on the table that can reconfigure and do lots of cool stuff. In our paper, we have defined this, different mechanical shells design. It can switch, simply different shapes, or, this light can, there's a single LED in the robot that can be extended for different expressions. But the main part for this project is about the motion translation, right? The simple rotation can be, shifted, translated to linear motion, or the speed can be, increased by using different gear ratio, or they can even, locomote using this different rotation shells. By switching shell, it can provide different input from users, like this slider input or rotation. But as I talk about this idea is building on top of swarm robots, multiple robots can also activate single shell, which is really cool. So, many robots can cooperate together to control one shell, and, it can detach and, attach to another one and do completely different motions, which is really crazy. And you could also imagine, what if there is like 100 robots that can like reconfigure and dock in different ways to do much crazier stuff. And this is an idea also, you can, the robots are utilized to assemble from one to the other, or stacking robots from one on top of another, then you can like spin really fast or provide really strong force. So basically the idea is like by combining them together, it can provide what beyond what single robot can provide. This is actually built on top of commercial off-the-shelf commercial robot commercial robot toy we bought from Sony. It's only sold in Japan right now, but we hacked this robot so it can have this like docking mechanism, which I won't go too much in detail because I'm running out of time. And by having this, you can also imagine how you can have this in your, real physical environment, where they can, provide different feedback, or, when you're hot, it dock into this fan and, generate wind, or it can dock to, this height adjustable screen. So, make your work at home much adaptable and reconfigurable. This looks another like toy, but we were collaborating with a car company where this could, how this tool can be used, research can be utilized for representing a future of city by switching between different shells like bus or cars. And so these represent different digital data. And you can also imagine how this can be used for more like playful storytelling applications, where almost like there is this backstage and front stage, where these robots are almost like actors on the stage, and they can switch their different costumes and appear in front of the audience or participants to create different expressions. This kind of like describes the future architecture, where we can imagine like how this can be expanded in a different ways using different research possibility. I think there's lots of ideas beyond what we have built, but I think one extremely interesting one is basically we have utilized this wheeled robots on the table, but what if we can use used this idea for drones, right? Drones can levitate and fly in different 3D space. And what if we can create a shells for drones? That would be much more exciting, isn't it? So that was really quick view of my research I have done at past 7 years at MIT. And kind of in the summary, I envision the future of this actuated tangible user interface to be incorporated into our everyday life beyond screens and keyboards and mouse. And I wish I can blend this joy of physical interaction with materials with robotic actuation and digital computation. And one that might be really cool for you to see is, this was one project we did when I started at the MIT, imagining how this can be, future of furniture, not only as a computer or screens, but how it can start, integrated into our table and move lots of different stuff and do lots of cool stuff beyond it. In my research, if you look at my web, you also find lots of other projects too. I also did shape-changing fluid or moving liquid droplets, etc., or like shape-changing tools that support you. And I have been working on lots of thinking of how we bring these research out of the lab. And I'm really passionate to not only just build and publish paper, but also exhibiting our work at museums in and outside of US. So once I move to Chicago, I hope to do more utilizing the community. And we also do lots of hands-on workshop, giving this new shape-changing material to children or students, and see what kind of new thing they would build out of this new materials. I would like to, I have a few more slides. I would like to end my talk about kind of the process of my research. So my research is always, about this cycle of making, trying, and thinking. I always get, it's not, when I come up with these weird ideas, it's not only I sit down on the table and think about and build it. It's not really linear. It's always this, circular process of me coming up with this random idea, trying it really quickly using available technology, and see and try to understand it from the almost like audience point of view, user point of view, saying how cool this thing is, how new this thing is, how impact I could make. So these looks really dirty on my table, or is it with all the tapes and stuff like that, but all these moments, how it really triggers my ideas further, push my ideas further. So I think keep building, but keep thinking, and keep this cycle going is really important for me. And with that, I think when I do research about this tangible user interface, the process itself is really tangible, right? And with this prototype, what I believe is, and what I believe is basically these prototypes themselves are really important too, but I think there's much more ideas or future beyond these prototypes. So I hope you got, lots of inspiration. I wish, I'm talking through Zoom, so you cannot really able to, you cannot really touch. But I think the value of bringing, these to museum and let people touch is also letting them to come up with new futures that I may not be able to come up with. So that's one of things I would love to continue when I move to U Chicago. I would like to go back to, so these are last few slides. But I would like to go back to the definition of actuate I originally introduced, which is about really, I describe as it is an engineering word, engineering term that causing a machine or device to operate or move. But through my PhD study, I found that when I look up in the dictionary, I found there's a secondary meaning, which is basically causing someone, basically people, to act in particular way. This kind of made me think it's a really really dry engineering word, but the actuate word itself means a lot about interaction design, right? How this technology really, actuate us is like one open question I would like to explore in my research. And as you have seen in my research, I think, I don't want my technology to be something that people just sit down and watch it. I think, as I described, this physical material, the tangibility really, motivate us, actuate us to use our body and hands to interact with them. So always body, hands are in the loop of all these like ideas. And with that kind of like, belief, I named my lab at the University of Chicago Actuated Experience, XLab for short. And I am currently busy moving to make a transition to Chicago. I'm starting in January. And my last slide is about basically, I'm actively looking for students. So please consider applying to the University of Chicago and join me to create actuating technologies. Thank you.
Wow. I wish we didn't have to, like, we had more time, and then I would love to learn more about. This was so fascinating. And there were moments in the presentation where I just like paused and went into this dreamy state. This is so, so incredible. And you beautifully described like how technology is not separate from us. It's not separate from human. And bringing that aspect and also including the community, I guess that's very, very valuable and makes your work so unique. Now I want to go back to school and enjoy the lab. But thank you so much. And I'm curious to hear what our young people think about it. So this is your chance. Feel free to ask any questions. And Ken would love to interact with you. Question, you can also share something that inspired you or just your thoughts and comments.
And yeah, I think moving to Chicago, I'm really started talking to students and coming up with new ideas there. So yeah, maybe you can follow my Twitter to keep updated about my lab. But yeah.
Yeah, you can feel free to unmute yourself. Also, there's a raise hand feature if you'd like. Use the chat. And meanwhile, I'll ask a question. I guess in all the presentation, something that stood out or captured my attention, like I was taking notes and I just stopped, was when you showed like your prototyping process with just the stop motion video. So when you think about that vision, like how do you translate that vision? Of course, in the physical form, like explaining that idea to somebody, but also working towards making a functional prototype, like a second iteration. How do you research and find out about the technology and learn in the process?
Yeah, I think technologies, maybe like when you compare to like 20 years ago, there are many technologies that become much more available these days. I think Media Lab is one of the big part taking. So for example, Scratch, they made programming available for children, right? Before that, it was basically much harder to program and stuff. But anyway, there are lots of tools, I use, which are like processing or Arduino, which are technologies that they are designed for like designers and artists. And I think, almost for me, it's about almost like, it's almost like drawing. For me, these like technological prototypes are almost like, drawing using, crayons and stuff like that, or paintbrushes. These technologies became much easy to, play with it and, so I can engage, my hands into the ideas than thinking too much about complicated stuff. So, and as you saw in the video prototype, I think I always think, what's the quickest way I can, make my idea into some shape that I can share with people. I think that is like sketching is one of them that you can draw and show to people, and making a video is another form to, convert your idea into something that people start believing about, or thinking about it. And I have this like fictional prototype that people can actually touch and feel and explore about it. So I think these are kind of like how I bring my idea to different reality level through sketch, video, and physical prototype. Sometimes also we just play around with cardboard, which I think it's even students, like junior high school students, elementary school students, can start doing with paper and cardboard. So I think yeah, that is basically almost like I'm doing this extension of playing with stuff to create my ideas.
Thank you for sharing that. Mr. Stewart's class, they're wondering about attaching sensors on the string or the line project to be able to monitor and track muscle motion. What do you think of that idea? Or can the sensors be attached in?
Yeah, so when we do, thank you so much for that. That's such a great hardcore question. Didn't get that here. But yeah, that's a great point. And when I build, actuated technologies or user interface, I think people look at the changing and action part of it. I think it's really the key. I realize it's a really key to integrate sensing into this actuator. So, it can detect how human, touch or interact and loop it back to the actuation. And actually for both the line form project and also the omni fiber project, the string really thin fiber one, they also both have sensors in it. So it can detect how you deform it, or yeah, for the omni fiber one, the lead researcher is extremely interested in like tracking, for example, your like breathing rate and giving it, guiding you how to breathe and etc. So kind of like it's really crazy to imagine how such technology can be woven into our everyday life. But yeah, to answer to your questions, yes, sensing is already part of it, and we want to really fully utilize, closing the loop of sensing and actuation for designing the human interaction.
Another question from Taolong. As you mentioned that you will try to make these impactful technologies work for the local community in Chicago, I'm just wondering, what are some of your visions on this? It's great to ask the questions about community.
Yeah, I'm moving to Chicago in 10 days or so, I guess. But so I'm still kind of like learning the city. I think looks really, interesting place to do research. It is the third biggest city in the US, and it has lots of like diverse community in different income and etc. like that. So one thing I'm thinking is, I described how I can bring my research into children as like providing workshops and etc. like that. So it's like how I can keep doing impactful research, but how I can bring these to people who may want to try and put their hands in. I didn't really talk much about my lab itself, but one thing I want to do is to design my lab to be like half museum and half lab. So we keep building stuff, but as I said, this prototyping process of like building and sharing with people and looping back to the idea is really important. So I hope lots of people, I can have like lots of open lab opportunity for people to come in and try. So yeah, is my video frozen? Okay, it's good. But yeah, that's the answer. Thank you.
Yeah, it's great that you are inviting people from the community to further inform your research and design. And I think that that's very incredible. And that happens very less. I wish universities and like these projects were more accessible to people. We have one last question time, and then we gotta unfortunately stop. Mr. Stewart's club, they're asking, are you planning on further to develop the form line to make it smaller, the line form project?
Yeah,
do you plan to
for
make it
sure.
smaller?
For sure, I hope to do. U Chicago has a department of molecular engineering, basically, making super tiny materials that is like smart and transform and do stuff. So I could probably collaborate with them to make it smaller, but definitely I would love to do.
I guess there's also like a lot of bioengineering based project also with like working
Exactly.
microbes at the tiny level to create that project.
Yeah.
Well,
So
this was so fascinating. Thank you so much for opening new doors to this incredible field of human computer interaction. And I hope like all of us will take some inspiration and explore projects that basically have actuation and dynamic element to it. So thank you so much.